Welcome to another tutorial of ANSYS 2018. In this video we will gonna see that how we analyze a truss in ANSYS Workbench 2018 from start to end, getting the results, and which each and every step I will make sure that each and every step of for the analysis of a truss is made clear to you. So first of all, what you have to open your ANSYS Workbench, and after that what you do, you just go and select your structural analysis type. So but I will be going with a rather different approach for this video. What I will be doing, I would define the geometry of my truss first of all. So I will simply go to the geometry and I will simply click on the geometry. And now for the defining the geometry, I have three different options. One is the SolidWorks, one is the design model, and one is the SpaceClaim. So I will be going with the SpaceClaim option. So I have clicked on my SpaceClaim and it will be open in a few seconds. So my SpaceClaim is almost opened in front of me. I will simply close this, and after opening the SpaceClaim, what you have to do is to first of all go to the file option and select your model units. So selecting the units, you would have to go to the SpaceClaim options, and in the SpaceClaim options I have this button of units. I will simply click on units and select the units. So what I will be doing, I will be working in meters. So I have select the units and I will simply press on OK. After the selection of units, you have to select your sketching plane. So I will be working in the XY plane. So I will say yes, select my XY plane, and I will be having a top view of this XY plane. After having this top view, what I will be doing is that I would draw my truss first of all. But what you do, you just go and draw the truss, and like this I am just drawing a random. So when you have go, so you see that I have just drawn this, and you might assume that I have drawn 4 or 5 of this. And when I go to the 3D mode, what you see is that you have a solid element instead of these line elements. You know that in case of a truss we have just these line elements. This is a line element, this is a line element, and this is a line element. But in between these line elements we have nothing. We have in case of trusses, but this is being shown as a solid element in front of us. So how to tackle this issue? I will simply click on Ctrl Z, and now you would go to the sketch options, and in the sketch options you would check this box, create layout curves. When you have checked this box, now again go here and draw. So for example, I say I have a truss 5 meter with length is 5 meter, and here I just say that it is I must say 3 meter at angle of 45. So simply draw the line, and now we simply join this line. Okay, now I will be again go here and draw a line at a distance of minus 5 meter like I have done before. So distance of 3 meter at an angle of 45. Simply draw the line, and I will simply click on this. So again I will be going here and draw one more component, simply 5 meter length, and after the 5 meter length, 3 meter length, and at an angle of 45 degree. So I will be having this. I will be drawing one more component, 5 meter in this direction, horizontal directions, and 3 meter and 45 degree in this direction. And now I will simply closing this. So now you can see that I have drawn the geometry of my truss. Now if I go into the 3D mode, now what happens? You see that it is we only have this solid elements, and there is nothing in between the solid elements. So after drawing the geometry, what you have to do? You have to assign the sections, that what kind of section your elements are made. There is this I section, this is the L section, this what is the shape, is this a circular shape, hollow circular, what kind of shape you have. So for this I will be going to the prepare and the profiles. I have these profiles, so I will go here and for example I select the circular tube as my profile. After selecting the circular tube as my profile, what you have to do, you have to define your profile. So in the profile I just considered a circular tube. So if I wanted to you say that change the radiuses, for example this is 0.02 meter, so I wanted that this should be, my outer radius should be 0.1 meter. So what you have to do, you have, so I just consider, I go here and I say that my outer radius should be 0.01 meter, and I just click on this, and in the geometry option simply click, go here in the beam profiles, in the circular tube, edit beam profile, the edit beam profile. So I am having this, so I would be having the my radius value, so I would be writing 0.05 meter here. So I have selected, I have given the radiuses value for my beam. Now I will go for my section. So now I will again go to the design, and in the design I have decided my section as circular tube. I would go to design, and here I will go to selection. I will select all this. I will again go to the prepare and create, click on create. Now these sections have been assigned to these trusses. Now my trusses are made up of these sections. After that I will go to the workbench option, and in this I have an option of share. I will click on share. I will select all this. I will simply click on this. So now my geometry is completed for the truss. After assigning the geometry, now I would discuss the purpose for going to the geometry directly instead of going to the analysis system, then engineering data, then geometry. So in this way I have defined a geometry. So I have the benefit that I can use this geometry for any one or more analysis system. So if I click on static structural system, so you can see that analysis steps of static structure has appeared in front of me. So if you click on any other, it would appear in front of you. But now what you have to do, you can simply share, if you wanted to share this geometry, like here for this task you can simply use this geometry. For this analysis you can simply use the same geometry for another. For example, I wanted the analysis of a steady state thermal analysis. So a window has appeared in front of me for the steady state structural analysis. Now I wanted to use the same geometry for this purpose as well. So what you can see, so you can see that we can use the same geometry for different analysis by defining a geometric component for an individual system, and I can then use these geometry for any of the analysis types. So I will click on delete, and I will delete this because I have to do the static structural analysis. After defining the geometry, I will go into the design modeler. So my design modeler has been opened in front of me, and in a few seconds my geometry will be loaded here. As you can see that my geometry is loaded in front of me. So you have a first of all, what I will be doing, I will be having the geometry in my xy direction. So now you can see that my geometry is in xy direction. So let me make it more clear to you. So now you can see that it is more visible to you. So I have defined the geometry, I have defined my cross section, I have defined the coordinate system. Now we will simply go on the mesh, and I will simply directly mesh it. So when I click on, my meshing has been generated, and you can see that, observe, you see you have different elements. If I just zoom it, for the different element, for each element you have different further elements. But you know that whenever we have to do the analysis of a truss, we should have each element as a single unit. We should treat each element as a single unit. So for this, I will simply go to the mesh control. In the mesh control, I will simply click on the sizing. In the sizing, I have to select the geometry. So I will simply click on box select, and I will simply select this. If I say vertices, and I will simply go and apply the geometry. And if I can select this, and now I will apply the geometry. Now I have applied it to the geometry. So in this here I have the type into element size. So what I will be doing, I will be click on the numbering of division, and in number division I will make sure that my number of divisions is equal to 1, and again after having the number of division equal to 1, I will again mesh it. Now after the meshing, you will see that I have a single element, single unit for each element. After my this, so I will go to the static structure, and in the static structure I would define the sports. So I assume that I have just uh, you can say that fixed spot here. So I will apply a fixed spot here. I say that I have a fixed spot here. I will apply sorry, I will select a fixed spot here, and I will simply apply the fixed spot here as well. So I have applied two fixed spot here. Now I want to apply the loads. So what I will be doing, I will go to the box select, and I say that I will apply a force at these three nodes. So I will apply the force, and I say that I apply the force by the components, and in the components I say that I apply the force in y direction. So I assume that my force is 30,000 lb pound per feet. So my force is applied in the downward direction to these three nodes, which is the 30,000 lb or 30 cubes force I have applied. After applying this force, what I will be doing, I will be simply going with the solution. So I have applied the loads. So one more thing, one very important thing, that I have to make sure that my structure is restricted in the z direction. Since I am doing the analysis of a truss in a 2D system, I am be using the xy plane. So I would have to make sure that my all the displacements at the node is restricted in the z direction. So I will simply apply to this geometry, and now for this I have the 0 in. So now my displacement is on. Now I will simply go to the solution, and I will simply go with the solving of this. So you can see that ANSYS is being solving this, and in a few seconds my analysis will be completed for the truss. So it is almost completed. So you can see that it has given me the warning message, the deformation is large compared to the model bounding bus. So since we have just assumed a random geometry, so it's just giving that the deformation is very larger. So now what in case of truss, we want a total deformation diagram, and in case of truss you know that the bending moments and shear forces are very negligible, and we have mostly the force we have is the axial forces, which is in tension or compression. So I say that I just wanted these results, and I will simply go on again, click on solve. So ANSYS has completed my solution. So you can see that this is my deformed shape of my truss. I have maximum force here, which is, you can see that here, and the minimum force which is at the fixed spot, minimum deformation. You know that we have used the fixed spot, and in the fixed spot we have zero deformation. So you can see that, observe the effect of the fixed spot. This is the one thing. And one more thing is that the axial forces, you can also see that these two members have are experiencing very high forces, and this member is also experiencing a very high force, and these members are experiencing very basically you say these members are experiencing the force in compression, and these are having the force in tension, and these are having the force in compression. So So this was the analysis of a complete truss. I hope that you would have liked the video. If you have any confusions, any type of confusion, you can comment below. I will surely try to answer your queries.